Section 6.1, this is the part 2 video. We're going to verify identities. You can always prove something is not true by an example. So you can do an example where it's not true, and that proves something's not true. But you can't do an example to prove something is true, because the reason you can't do that is because you'd have to prove every single solitary one would be true. And you can't do that because there are infinite things to try. So you can't try infinite things. So you can prove something's not true by example, but you can't prove something's true by an example. So I want to verify the identity cosine of x, cotangent of x plus sine of x is equal to cosecant of x. First thing you do is you're either going to pick the right side to work with or the left side. Rule of thumb, pick the side that looks more complicated, because it's easier to take a complicated side and make it more simplified than take a simplified side and make it look more complicated. So I'm going to work on the left side. So I'm going to put everything in terms of sine and cosine first. So I have cosine of x, cotangent, remember, is cosine over sine, plus sine of x is equal to the cosecant. That's what I want to prove. So let's see if I can make that look like that. Cosine times cosine is cosine squared. So I have cosine squared of x over sine of x, plus sine of x. There are multiple ways that you can do this. You can solve this equation. I am going to get a common denominator, but you don't need to. I can do also a substitution here, but I'm going to do a common denominator. So I have cosine squared of x minus, or over sine of x, plus, if I multiply this side by 1, but I'm going to call the 1 sine of x over sine of x, so that's what I just did, this will end up to be sine times sine, which is sine squared over sine. So I have my common denominator now. So I have cosine squared plus sine squared all over my common denominator. And if you don't need to do these two steps here, you probably need to do this one. You might not even need to do this one. You could write it just right to there if you see it. And then your Pythagorean relationship, sine squared plus cosine squared is equal to 1. So then you have 1 over sine, which is cosecant. And you're done. Not the only way to do it, one way to do it. Next example, verify the identity. You have a right side, you have a left side. The left side to me looks a little more complicated. So looking at the left side, what can I do there? Well, do you know that 9 is a perfect square? And 16 cosine squared is a perfect square? This is the difference of perfect squares, so you remember from algebra, I hope, that you could factor that. So you could take that numerator and factor it into 3 plus 4 cosine times 3 minus 4 cosine. So it factors. And then those cancel, and I'm where I need to be. 3 minus 4 cosine of x. Look, same thing. I'm there. You're done. Next problem. Verify the identity sine minus cosine times sine plus cosine is equal to 1 minus 2 cosine squared of x. So when I'm looking at this one, you can decide which side to work with. Look at it, the right side, the left side. I think the left side looks a little more complicated, so I would work with the left side. And I would FOIL it, first, inner, outer, last. First, inner, outer, and last. So I'd work on the left side, and I would multiply it out. Okay? So there's the left side multiplied out. Sine squared. Outer, inner cancel out because that's a plus and a minus. The last terms minus cosine squared. And then look at where you're going. I'm right here. I need to go to here. This only has cosines in it. So I need to get rid of that somehow. Maybe make it a cosine. Look at your relationships. Sine squared plus cosine squared is equal to 1. So sine squared is 1 minus cosine squared. I said, remember that, so this is what I just said, sine squared plus cosine squared of x is equal to 1, so sine squared of x is equal to 1 minus cosine squared of x. So I'm just going to do a substitution here. So I'm substituting. So I have 1 minus cosine squared of x, that's sine squared of x, minus my cosine squared of x. 1 minus cosine, combine your like terms, so I have minus 2 of those. And voila, I just proved it. Okay, next example. Example 12, verify the identity. Sine cubed of x plus cosine cubed of x is equal to sine of x plus cosine of x times 1 minus sine of x cosine of x. If I were doing this, I'd work on the right side. You might be able to work on the left side if you know some factoring, if you remember some of the formulas for factoring, but I'm going to work on the right side. So let's see, right side. I think I will multiply it out. Like I said, this isn't the only way to do it, so don't always assume that just because I do it one way, it's not the only way to do it, okay? So I'm going to work on the right side. So I am taking my right side and I am foiling it. So I have sine of x are my first terms. My first and last term would be minus sine squared of x cosine of x. My inner terms would be cosine of x, and my last terms then would be sine of x cosine squared of x. And like I said, this is not the only way to do it. Okay, so now that's where I am right here. So let's see where I am. I have a sine. I have a sine squared with a cosine. I have a cosine. And I have a, let's see what else I have. And I have a sine with a cosine squared. And I want to get to sine cubed, cosine cubed. You could do some substitutions probably. You can group some things together. I think I will probably, let's see, group things together. Does that work? Let me see, sine squared, sine, cosine. So if I take, let's see if this works. If I take that, and I take this, and let me see if that will work if I group it together. So let's look back, stand back, look at it a little bit. And I want to see if I rearrange the terms, can I factor out something? So if I have my cosine, sine squared, yeah, I think this might work. Yep, let me try it. So let me rearrange terms. Hope I did that next. Let's see if I did. Okay. Maybe I can use that if I rearrange terms. That's what I'm thinking, actually. I'm thinking if I group these together, I can factor out a cosine, and I'll have a sine squared in there. And if I group those two together, I'll factor out a sine, and I'll have the cosine squared there. So that's really what I'm doing. And some of these do take some thinking. So I group stuff together. Let me color code it so you can see what I group together. Cosine of x, and that sine squared of x, cosine of x, and the minus belongs with it. So that's what I did first. And then I grouped the sine of x minus sine of x cosine squared of x. So I grouped those together, and then from this I can factor out a cosine. So I'm going to factor. So I can factor out a cosine, and I'm left with 1 minus sine squared. And here I can factor out a sine. And I forgot to write the x's. There really are x's here. Forgot to write them. And I have a 1 minus cosine squared. And then now it's really easy. I can do some substitutions. 1 minus sine squared is cosine squared. 1 minus cosine squared is sine squared. So I'm going to do a substitution. do substitution. And remember, you do have x's here. Cosine cubed, sine cubed. You did it. We're done. So I grouped stuff together and then I factored by grouping. Like I said, probably not the only way to do it, but it's one way to do it. The next one, example 13, verify the identity. When I'm looking at both sides, right and left, the right side, the only thing I could do for the right side is do a substitution. And then instead of cosine squareds, I'd have sine squareds. And I wouldn't have a cosine and a sine. So let me look at the left side. Left side. Perfect square, perfect square. So let's factor that. It factors into the cosine squared minus sine squared times cosine squared plus sine squared. So there's what it factors into, the plus and minus. So now when you're looking at it, look at where you're going. Don't just automatically say, oh, this is 1, because this is where I need to go. I need to go places where there's only cosines. So if I need to go somewhere where there's only cosines, maybe I'll distribute, or I'll substitute in for a sine squared. Maybe that'll work. So that's probably what I would do first. Or I might do the substitution of 1 and then just factor in here. So let me just do this one first, because this is 1, but I'm not going to put it at 1 yet. I'm just going to do this part first. Cosine squared of x minus sine squared is 1 minus cosine squared. Oh, wow. I think we're here. That did it. I'm not doing anything right here yet. Cosine squared minus 1 minus cosine squared is plus 2, because it's negative. Distribute the negative, that's how I get plus 2. So do the substitution there of 1. Okay? And hopefully that's what I did here. I did a substitute. Yes, I did. Okay. When you do a substitution there, you substitute in, instead of sine squared, you put cosine squared in, and that's what I did. There. Distribute the negative, and you're there. There, and there. Okay. And like I said, I was just doing it one at a time, just in case this was a little different. I was trying to do one at a time. But the right side equals 2 cosine squared, or the right part of it equals cosine squared minus 1. So then I can do the substitution of 1. Example 14. Verify the identity. When you're looking at example 14, right side, left side, one side looks a little more complicated. To me, the left side looks complicated, so I would work on the left first. So I am going to work on the left side and get a common denominator. So if I multiply the first term by secant of x plus 1 over secant of x plus 1, and the second term by secant of x minus 1 times secant of x minus 1, and that's what I have right here, I will have a common denominator. So distribute and FOIL, and when you FOIL and distribute, this is secant squared minus 1, this is secant of x plus 1, plus secant of x minus 1, and my common denominator. And you can just write it as one fraction, just one denominator. Secant of x plus secant of x is 2 secant of x. Positive 1 plus a negative 1 is a 0. Look at where you're going. 2 secant of x, cotangent of x. I already have a 2 secant of x, So let's not do anything with that yet. But maybe I can do something there. Look at your identities. Secant squared minus 1. I hope you know that that's tangent squared. That's what I just said here. Okay? And if you want to write it differently, I could write it like that, because then you'll easily see that that's cotangent squared, which is what I have for my identity. Okay? Next example. I think I have a couple more examples, then I'll be done. Verify the identity. Cotangent squared plus tangent squared is on the left side. And on the right side is secant squared, cosecant squared minus 2. I probably would work with the right side because of the secant, cosecant that are multiplied together. That looks a little more complicated to me. So I would work on, whoops. Erase that, sorry. Okay, is this going to work then? Yeah, it does. I would substitute on the right side. So I would look at my right side and see what I have there. I have a secant squared. I also have a cosecant squared. So I would do some substitutions. So secant squared is 1 plus tangent squared. Cosecant squared is 1 plus cotangent squared. And then I have the minus 2. FOIL, and you have 1 plus tangent squared plus cotangent squared plus tangent squared times cotangent squared minus your 2. Tangent and cotangent are reciprocals of each other. So I hope you know that that is equal to 1. So I have 1 plus 1 minus 2, which cancels out, and I have my ending. So if you want to see more of it, you don't need to write it. If you wrote that right there, you can see the 1 plus 1 minus 2 cancels out. Cotangent squared plus tangent squared, cotangent squared plus tangent squared. Done. This is the last example I want to do for tonight. Verify the identity. Left side looks more complicated than right because it's a fraction. So I'm going to multiply by the conjugate, which is 1 plus cosine of x. Top and bottom. So now my bottom will be 1 minus cosine squared. So my denominator is 1 minus cosine squared. I'm going to leave the top and not multiply it yet. Maybe I'll multiply it in a little while. I have to do it step by step because maybe something will cancel out. 1 minus cosine squared is sine squared. Sine over sine squared, you can do some canceling out here. Okay, that's what I just did there. I can rewrite this as 1 over sine plus cosine over sine. 1 over sine is cosecant. Cosine over sine is cotangent. Done.